Hello, guys. Thanks for joining us today. Today we'll be speaking about functional programming. It's a paradigm that allows you to write more maintainable and readable code. The speaker today is Tornike. He will tell you a bit about functional programming and show some examples of code, how you can use it in Java. As always, I remind you that you can write your questions to the chat. We will try to answer them all. And with this, I'm passing the word to Tornike.
Okay, hi guys again. My name is Tornike. I've joined EPAM a bit over a year ago. I'm a senior software engineer, and we have a really interesting topic today, which is the functional programming. And so the agenda would be I'm going to go through some of the slides, explain in theory what it is, and then we're gonna do some examples. And yeah, we will look for your questions in the chat as well, and try to answer them as best as we can. So can everybody see my presentation? It's probably visible, right? I already did a small introduction about myself. So yeah, this is me. And okay, let's just get to it. So functional programming, what it is, how it is, and so on. So we know that the programming languages fall under some of the categories, that is programming paradigms. Well, what is a paradigm itself? It's basically an approach, a way of programming. And since we all are very familiar with Java, we know where Java falls in the structure. It's obviously an object-oriented programming. But today we're going to be speaking about the functional one. So a small difference between imperative and declarative programming languages. Declarative is basically a paradigm that just says what needs to be done in the most simple words, as opposed to imperative paradigm, which tells how it should be done. So imperative is a collection of statements, step-by-step instructions, variables changing their values, and so on, just like we do in Java. But the declarative one would be having expressions and just having an input, then a functionality, and evaluating the output that is based on the input. There are many programming languages that incorporate functional programming. Java was obviously not the first one. Here are some of the most popular ones: Clojure, Haskell, Scala, and Elixir. Some of them don't rely only on the functional programming. For example, Scala also has elements of object-oriented programming. So today we are seeing more and more programming languages that can achieve more than one paradigm. And same goes for Java. Of course, it's an object-oriented programming language, one of the most popular ones. But we also can accomplish functional programming. And when we get to the real examples of how to use it or when to use it, it's gonna become much clearer about what advantages the functional programming gives us. If you just want to get started in functional programming, I would suggest probably to start with Haskell, which promotes pure functions. It's just one of the best functional programming languages. But again, we're going to be focusing on Java now. So what is functional programming? It has many definitions, but one of the easiest ones would be just using functions to the best effect for creating clear and maintainable code. So it's organizes code more easily than object-oriented design does. And so it says that it's a set of approaches to coding, right? And we are very soon going to see how it works and what it does. Some of the characteristics of it, some of them might be pretty different from the object-oriented design, but like we said, it focuses on the results, not the process. So it focuses on the the function and its output, and not the flow of not the control flow of the process. So again, functional programming would be what needs to be done, and object-oriented and other imperative programming would be how it needs to be done. Data is immutable. We come across this term a lot in Java, data mutability. So that's not a concern in functional programming. And yeah, basically we have smaller functions. We decompose the main problem into smaller functions. And well, it does not directly support the iterations like loop statements and if-else conditions, but we're going to see what we can achieve without actual if-else statements. And so what do we need to do to accomplish functional programming? How do we write functional programming in Java? So since Java 8, which was released, I believe, in 2014, it was one of the biggest releases in Java history, one of the most popular and stable versions, Java 8. We are able to accomplish functional programming using functional interfaces and Lambda expressions. These are the two of the most known terms that revolve around functional programming in Java. And okay, theoretically, it's very easy to define this, but we're going to see in the examples about what it really is. So functional interface has a very easy definition. We all know interfaces, right? And we all know what they contain: abstract methods, default methods, static methods, and so on. Well, a functional interface is just an interface, a regular interface, that can only contain one abstract method, meaning it can contain many default or static methods, but it has to contain only one abstract method. That is very crucial for functional programming to be achieved. Otherwise, we would not be able to do so, and we'll see why. So any interface we have that only has one abstract method, we can call that a functional interface, which is one of the pillars on which functional programming in Java is built on. And one of the other very interesting topics we have is Lambda expression. So what is Lambda expression? It's a way of writing in functional programming. It's basically an anonymous method, means that the method, we can write methods in Java that doesn't have a name. We already know that using anonymous classes, but we can also do that with the methods. So with collaboration of functional interfaces and Lambda expressions, which has a pretty, I'd say, specific particular syntax, which might be very new to some of you. It doesn't seem like Java at all. We are able to achieve functional programming between these two. So any questions you might have, feel free to write them in. Otherwise, we can be moving on to the actual live coding where we can demonstrate what functional interfaces and Lambdas are.
Yeah, I don't see any questions by now. I think they will appear a bit later.
Okay, so we're going to be live coding now. I'm going to code everything from the scratch. I think that's a very good way, instead of just copying and pasting the whole code. So I have my IntelliJ setup. I just started a new project from the scratch, just chose the template, command line app. So we only have the main class and the main method. And now I'm going to be creating some classes and some interfaces to demonstrate what functional interfaces do. So one of the most simple ways to demonstrate how functional programming works is using threads and our runnable interface. So let me just forget about the main class. Let's just create a new class. We can call that more than Java. That's the community, right? More than Java class. And we want to run threads, right, under this class. So what are the ways to create a thread? Either you extend the thread class or you implement a runnable interface. And if you look that up, it's mostly better to implement runnable interface, so you will have a room for extending other classes. So that's what we're going to do. Implement runnable. Nothing new here. We all know what this does, and we also understand that red underline because runnable interface has an abstract method called run, and whenever we implement that interface, we have to override the run method. So that's a very classic example of implementing an interface. You create a class, you implement an interface, and whatever methods this interface has, whatever abstract methods this interface has, we have to override it. And there's no other way of achieving that. So we just print something in the thread, just to let us know that we have a body for this run method. And what we can do, what's the next step? So we can get to the main method. If you guys don't know, and if you are using IntelliJ, PSVM would be the shortcut for public static void main. So after you press enter or tab after PSVM, you get the main method automatically. And so what's next to do? You instantiate a class. You create an object of the more than Java class, like that. Just name it whatever you want. So you just create a new object based on the class, and you call the run method to it, right? So you call the run method to the more than Java object. So that is a classic way, again, of implementing an interface. You have a class implementing an interface. You override all the methods that this interface has, all the abstract methods, and then you create an instance of that class and just call the method. Very easy, nothing new. We all do that, but there are better ways to do so. What if I don't have to create the class more than Java myself? Or what if this portion of this code can be considered boilerplate code because I might not need it? So what do we do? What are the other ways of doing that? Let's keep this version here, and let's create a new class. So we just have to create a class. We're not able to create a public class because we already have one public class. Let's say anonymous class, because that's the implementation we're going for. Okay, so we have an so-called anonymous class, and we are trying to start a thread again. So one way to start a thread was to create a class, implement it, and blah, blah. We already seen that. But there are other ways to start threads as well. So let's just go with the, again, PSVM, the main method. And let's do something. So we know that runnable interface is the one that contains the run method, where our thread is going to be running. So we know that runnable. Okay, let's just, technically, I'm allowed to do that. I'm allowed to store my more than Java instance to the runnable type because it's an interface, right? And it implements it. But you're not able to instantiate an interface. That's one of the first things we learn about interfaces, that you cannot have new runnable, right? Because that's the whole point of an interface would be that you are not able to instantiate it. So what I'm trying to do here is actually instantiating an interface. New runnable seems very weird. I should get a error because you're not allowed to instantiate a new interface, but you can. Actually, IntelliJ helped me do that. You can, and let me write the semicolon here. You can actually pretend that you are instantiating the interface without having to create a class that implements it. And what you are doing here is instantiating an interface, but it's not actually instantiating the interface. What you are doing here is writing the anonymous class. So between these curly braces, on line 2021, 22, 23, you actually are implementing the runnable interface, but it's an anonymous class. So you don't see a name of any of those classes, but what you are actually doing is implementing it. So I can do the same thing. Excuse this, I don't know what color it is, yellow, brown, it's from the solar lint. So in the thread, whatever. So we actually did the same thing as above, but we didn't have to create a class because we don't need to create a class. And what we did is we just created an interface, and we are overriding the run method within an anonymous class. Again, a very easy name because you don't see where the class is. It's actually hidden between these curly braces, and it does have no name because you don't need the name of the class so far. All you need is to be able to override the run method. And that's one of the ways of instantiating a runnable. And what you can do very easily is just call the run method to it. Calling the run method on an interface instance where in reality it's actually a class that you are implementing. So anonymous class implementing an interface on the go. So we are already like moving away from the object-oriented design because it can become complex, right? Object-oriented design tells us that whatever you do, you have to create classes, you have to create objects, you have to create methods. That's where that's how Java works, right? But there are some other features we can use where we don't have to do the boring stuff of creating a class, which you probably might not need. The only reason I created the more than Java class is to be able to run the thread. And I did the same. I achieved the same thing with fewer lines, and it might look a bit different, but wait till you get the Lambdas. Okay, there is do we have any questions in the chat?
Yeah, actually, we have one comment. Why should the data be immutable in functional programming?
Oh, that is actually, I was looking that up today about the data immutability. I think it has to do that you don't have to pay attention to the states of the objects that you have and how the states of the objects are changing. In object-oriented design, that's one of the very important things to pay attention to. But in functional, you just have data and you manipulate data and you have output. So to me, it makes things more simple, and it makes the code easier to write and manage as well, because you don't have to specify how you should do stuff. You just have to specify what you want to do. That would probably be my. If you have a better formulation of the answer, go ahead. But yeah, that's my take on that.
Yeah, I would just say that it's safer, especially in a multi-threaded environment. If two threads are trying to change the state of one object, it's just a nightmare every time. But if you have an immutable data and you create a copy of the data for each thread, and thread is working with its own copy, it's much easier to manage. Yeah.
Yeah, great.
Yeah, we don't have any more questions, but just I have a small comment. I think runnable.run doesn't start a new thread. You have to make new thread and pass a runnable there and then call start.
That is correct. So what you mean by that is
yeah, so that's just an example of implementing an interface, not run, but start.
Yeah.
Okay, I think we can go further.
Okay, so that was the second version of implementing runnable. Actually, okay, let me do the third one, and then I will explain a bit more about runnable and why I chose that as an example. It's just one of the examples. It has nothing to do with threading in particular. It's just one of the functional interfaces that Java has. Okay, let's create another class. I think that would be an easier way instead of just deleting all that stuff. Okay, let me zoom that in. Okay, now we get to the Lambda part. That's where it gets easier and more complicated at the same time. So let's get the Lambda version, we can call that. And same thing, we wanna implement runnable interface. We wanna override the run method and we wanna run it. So how else can we do that? We saw the version where we would create a class that implements the runnable interface, overrides the run method, and just runs it. Very easy, very straightforward. We had a version where we created an anonymous class where we didn't specify the class name anywhere, and we just implemented the run method actually within declaring the object itself. And there's a new other version we have. So you have to have Java 8 or latest version to be able to achieve that. Okay, we can just start with, we are not implementing anything, it's just a class. And I'm going to try to create a runnable instance. And okay, there are ways to do that. Okay, just follow me on this. It might seem very weird. Okay, this little arrow to the right is the most crucial part of the Lambda expressions, and I'll just write it, and I'll just in a thread, something like that. I'll just show you what it does. I can do that in one line actually, and what I can do is, sorry. Oh, I need a main. I forgot the main method. Sorry. Okay, I'm gonna put that in the main method, and just call the run method. Yeah, it's correct. It's not the way to start the thread, but it's a way to just call a method within an interface. So what did I do here? It's only one line. So that's the one of the benefits of using functional interfaces and Lambda expressions. What I have done is trying to instantiate the runnable interface, and I am actually this curly this braces. Yeah, these braces represent the parameters that are needed in the run method, and run is we can just go there, is void, type of void, which means that it doesn't return anything and it does not have any parameters. So that's why we have empty braces. So that's the syntax of Lambda. You start with parameters of the method you are overriding. There's only one method you are overriding because you are using a functional interface, and that functional interface has only one abstract method. Let's get to runnable again. It's very easy to see. It's annotated by @functional interface, and it only has one abstract method. So whenever you are trying to implement that, we already know what method you are going to have to override, because again, only one method. So Java understands that when you are creating an instance of runnable, you have to implement the class and override the method. These are the two steps you have to take, right? But you can achieve all that using no class declaration and no method declaration. So it's almost like an anonymous method. So let's get to the syntax again. So the first braces tell us that the run method takes no parameters. That's why it's empty. Then we have the Lambda sign, whatever you want to call it, arrow to the right. And afterwards, we have the body of the run method. So you are actually overriding the run method on the right side. How does it know that you are overriding the run method? Because it's a functional interface and it only has one method to override. So you don't have to specify the name of the method you are overriding, nor do you have to create a new class to implement the interface. So basically in this one line, what we are doing is implementing the whole interface on the run and overriding the run method on the run as well. So that's one of the examples of Lambdas. If it had an argument, if the run method had an argument, we would have to specify the arguments here. And I'll show you one of the examples where we ourselves gonna create a functional interface. So again, why I chose runnable? Because it's one of the functional interfaces. Java has many provided, and it very makes sense when you are dealing with threads, and it just might look kind of ugly. It can get a bit uglier. This is the most simple version because it has no arguments and there's only like one line of code. Of course, you can have several lines of code, like another, and you have to put this in these braces. Okay, it looks kind of ugly, but yeah. Actually, what you can do, what the compiler is going to suggest, do you see this? Go back to the anonymous class part. Do you see this grayed out part? Because my IntelliJ is telling me anonymous new runnable. I don't think if you can see it properly, but I'll read it out. Anonymous new runnable can be replaced with Lambda, and you just have a replace with Lambda button, which you can press, and yeah, we get the same result. Runnable, and then the Lambda part comes in. So again, let me get back to the old version. It's very far from the object-oriented design. It's not what we are used to. We are not creating any classes. We're not creating any methods. We are just doing the system what to do. That's the what part of the functional programming. Just do. I don't have to worry about how the thing should be done. How is it gonna implement the class or override the method? I don't care. I'm just gonna tell the system what to do, and that's one of the most beautiful parts about functional programming is just straightforward. Just tell the compiler what to do, and you don't have to spend too much time on creating different interfaces or classes and so on. I want to get to the second example where we are going to create the functional interface ourselves. But do we have any questions before that?
Checking it. No, we have no questions, but yeah, I will steal 30 seconds with a bit of commercial. As you guys, I hope know, we have a free Java online school that starts with the very basics of Java, with writing main methods, and goes up to cloud and other modern frameworks. And you can enroll for free on mjc.school. Okay, so the commercial is over, and actually we have one question. Why we can add default methods in the functional interface if we cannot use Lambda for the default methods? So why do we need a default method in the functional interface?
You can certainly create a functional interface without one. And if you add a default method to a functional interface, and you would also have an abstract method, our Lambda would not understand which one to override. And yeah, what's the point of using default methods if you are constantly trying to override those? One of the ideas of the default method would be to have a default logic to it. So yeah, I don't think you can override default methods using lambdas. Can you? I've never tried it. We can try it here.
I actually don't know.
Yeah,
The point of having a default method in the functional interface is to allow some default implementation. So if you implement interface with a usual class, you can override these default methods. But still, you have only one abstract method, so it can be implemented via Lambda. If you just have two abstract methods, you would have to create a new class to implement these two methods. So it's like for backwards compatibility, I would say, uh, including adding some default methods in Java interfaces. I think some iterator.remove methods what was added in Java 8 only when the default methods were introduced.
Yeah, that makes sense. Okay, should we move on?
Yeah, I think yes.
Okay, so very quick, I'm going to do a similar thing, but we are going to be creating the functional interface ourselves, and we are also going to be adding default method to see what the behavior might be. So I just created an interface called addable, inspired by runnable, and I'm going to annotate that as a functional interface, and it's yeah, of course we need a method for it, and just so you guys know, again, when you are declaring a method in an interface like int add, and let's have it with the parameters this time. By default, this method is public and abstract, right? Let's not forget that. So we can actually do it explicitly, but the compiler will go, this is redundant because it's unnecessary. By default, it's public and abstract. So we have a working functional interface with one method called add that takes two parameters. So what we can do now is, one thing we can do is implement this interface using a class, but we've already done similar stuff with runnable, so let's not do that now. Let's create a new class. We don't have, okay, let's do addable, okay, addable, yeah, okay, let's just say it's an implementation, but it's not. We are not gonna implement this interface like we used to with object-oriented design, because that's boring for us. What we are gonna do is, let me create a main method here. Okay, sorry if I keep zooming in and out. And just like we learned, you can try to instantiate the addable interface on your own. So addable, give it a name, and let's get the Lambda now. So we know that what we are doing now, it starts with the braces, then the Lambda part, and then the statement, right? So in the braces, we have to put in the parameters that this method takes. We have a add method that takes two parameters. We are obviously overriding this add method, and we can do so by passing the parameters. You can actually do that without the type, just A and B, that's whatever you want to call it, and just return A plus B. That's one of the ways you can put that in braces if you want. Same way you would put some stuff in the braces where you're making any calculations. And what we can do is, okay, just let me go through it one more time. I'm trying to instantiate the addable interface, and with using lambdas. So there are two parts of the lambda. First, we have the parameters in the brackets, if that's called the brackets. And the second part is the arrow to the right, and then the actual method body. So this operation could be done differently. Like I would have to implement the interface myself. I would have to override the add method and return a plus b, and then I would have to create an object. But I can do all of that in one line. And how we can like test it, I can actually call the add method to it and pass the parameters. So we are calling an add method to it, passing two parameters. We have the method body here to the right part of the Lambda, which returns a plus b. I think you can actually do something like that. I'm not 100% sure, but let's go for it. You could return it like this, yeah, but you don't need the return statement because it gets it. But that's the body of the method, so it's returning a plus b. And what I'm doing is the same thing, but it doesn't need it. It can be much easier. So a and b are the parameters of the method you are overriding. The method you are overriding is the add method, and you are just adding these two numbers up. Just run it. Yeah, we have the answer 30. So it was we were able to successfully override the method and add these two numbers together. What we could also do is, like we said, default methods are allowed in functional interfaces. So any default method really that needs a body, default void.
And returning to the default methods, we had an answer in the chat that if your interface has only one default interface, only one default method, you cannot create an instance of this interface using Lambda. So you need an abstract interface for that, an abstract method for that. Sorry.
Yeah, that makes sense. So yeah, I was able to add the default method to it with the compiler is fine. I can run the code myself, 30. And what I can do is try to add another method that is not default. Oh, also, let's get the static. I can also add static methods to it because it's not interfering with our Lambdas, because our compiler still knows that when you are creating Lambdas within this interface, you are overriding the add method only. But something might happen if we have another add. That's a really bad name. And okay, let's not have it. So what I did is I just introduced, let's say it has 3 parameters. I just introduced another public abstract method to this interface called another add, and now we have a problem. Okay, so now our Lambda is not understanding what we are overriding, how we are overriding it. So the whole design of functional programming is just we just broke it. That's what it is. We just broke the design. So you won't be able to do that. It's a very good example of you need to have only one abstract method to it. So once we I can remove the first one. So we now have another add only. So this is also an abstract method, and this interface qualifies as a functional interface, but we still don't get it because it's very easy why it's not working, right? It needs the exact amount of parameters. So let's delete this second and let's just leave us with the add, and it's working properly. So one thing, you can also specify the types in the parameters, and you can put those in braces, curly braces, whatever you like. But they're pretty might look kind of weird at first, but once you do it, it's very easy actually to get your hands on it, and it can help you a lot during your programming. And one more small thing that I wanted to mention was so where is it applied, right? Like we said, Java has many functional interfaces on its own, runnable being one of them, but we still have several of those. And again, we can create our own functional interfaces. You have to annotate that. Not sure what's going to happen if I don't. Probably the code will work properly. My guess, yeah, it's working properly without the annotation, of course, but let's all do that. And
yeah,
one
briefly jump in. This annotation is needed to verify on the compile time that your interfaces that you intend to make functional are actually functional. So the code would not compile if you add the second method.
Because if I don't have this method, for example, so this is an interface with only one default method or one default and one static method. It's not a functional interface, so it's telling me. So that's one of the examples. So yeah, it can be pretty helpful.
Yeah, so it's not required, but it's better to use it. Yeah, and I'm going back to the chat.
Okay, and one more thing, what I wanted to show you is so functional interfaces and Lambda expressions made our life easier in Java in so many ways. And one of the ways would be iterating through a collection. Let's just start there. Let's just create a very simple class. Collections. No, I'm not going to call it collections. Or then is that NTJ? Is that the yeah, whatever. Let's just call it that. And let's just say we have let's add a main method, and let's just say we have a collection. Very easy. Sorry. So list of integers. Let's say let's call it numbers. Okay. Which is okay, I can do arrays as list and 10, 20, 30, 40, 50. What? Okay. And let's just import this. Okay, we just have a list of numbers. And let's just try to iterate through that. What we know is, let me, okay. And let me also, yeah, that's probably better. So how would we iterate through this list? One of the ways would be a ForEach kind of thing, which basically means you can actually type the name of the list .for. That's for IntelliJ users, and you can press tab or enter, and it will populate the ForEach loop for you for each number in the numbers collection, and you can just print the number, right? That's one of the easiest ways, and we can just do this. We all know this. We've all done this. So yeah, iterating through an array list using the ForEach, which we have, but there's also one other way we can actually iterate through that, and it has to do with Lambdas, and it's pretty fun. So there's a ForEach method, which was added probably Java 8 or probably a bit later. Not sure, I have to look that up. So we have the ForEach method, which we can call on collections, of course. And it takes, this is a method that takes a functional interface as a parameter. So that's a new thing. ForEach method, let's get to the ForEach method, takes this consumer thing as a parameter called action, and it does its logic, right? So what is the consumer actually? Consumer is one of the functional interfaces in Java, which only has one public abstract method called except, generic type, void, not returning anything. So what we are doing is we are passing a functional interface as a parameter to the method. That's one of the uses of Lambda expressions, and there are so many things you can do with it. But yeah, okay, let's do it. So you can just do numbers. Okay, any number, like number, and number is the parameter, and then we can add the logic to it, which would be just print the number. So I'm not sure if this would be the proper way of organizing a Lambda expression, but there are some situations where we have chained method calls in Lambdas, and each line starts with the dot. But in this case, yeah, I think it's okay if it's on only one line. Okay, so what we did here, so many things we did in one line. So we called this ForEach method that we know takes a consumer as a parameter, and we also know that this consumer is a functional interface that has only one method called except, and it actually calls this except method from the ForEach method. So we are overriding the except method from the consumer interface, and we're just saying that just print it. That's the logic behind this method. Just print it out. That's what we're going to do. And let's see if this works. Yep, it's working properly. So yeah, that's also one of the ways you can, and there are so many other functional interfaces that you're going to be using besides consumer. And I think it's a very fun and interesting way to continue learning Java because it's pretty different. And yeah, I remember the first time I came across Lambdas, yeah, I was kind of freaked out, but slowly it made sense. But again, there is no way of achieving Lambdas without having functional interfaces. That's where it stands on. That's the base of any Lambda expression. So we have some methods that take functional interfaces as parameters, and you can actually, so this line, this portion between the braces is actually an instance of an interface, right? Because this ForEach method takes an interface as a parameter. What we are doing is actually implementing that interface on the run as we go, and also overriding the one method that this interface has. This one method is except at this point. There's a supplier function. There are many other functional interfaces that you're going to be using. And I've heard you guys also did streams. I mean, streams API, hopefully. And yeah, streams is also very heavy on Lambda expressions and functional interfaces. Streams was also one of the main Java 8 features. So yeah, that's probably all I have for today. I hope you guys are more interested in functional programming in general, and especially in Java, because you're going to be using it a lot. Especially also in web development, you're going to be using it a lot. So yeah.
Yeah, we actually have one more question. What is better to use for each cycle or method?
Sorry for. I didn't get that.
What is better to use for each cycle or method? So you showed two examples. Which of them is better?
Oh, you iterating? You mean iterating
Yeah.
Well, depends on what you want to do in the ForEach method. So this is a very easy example where we just printed the numbers, but I think that one of the main reasons of ForEach, adding the ForEach method in Java, probably 9, that's my guess, but I'm not sure, was to make iterating collections easier. So I'd say writing it I don't have any any actual reasons why I would use ForEach over regular loops, but because behind the scenes the ForEach actually loops it, but it's abstracted from you. You don't care about that. But of course, at the end, it has to create a loop, right? So the ForEach method creates a loop for you and just calls the accept method, and the body of your accept method is just to print it. I think that's this is clear. It's very readable. I prefer this version, but in terms of performance and stuff, it's just same for each loop at the end of the day. So I think it's up to you.
Yeah, I agree, but there are other methods that accept functional interfaces. For example, list has remove if, I think the method called, and it removes the element from list that satisfies some predicate. And methods like that can be more efficient if you use them instead of simple cycling and removing elements.
Yeah, that's true. Yeah.
Because the exact implementation of the list that you have can have some optimizations inside of it that you cannot achieve because some fields are private and some API is private. So I would say that for each and just printing the number, I would prefer cycles. I think they're more readable, but yeah, it's up to every programmer, and some more complex cases, passing lambdas can be better.
Yeah.
Okay, I don't see any more questions, so I think we will be wrapping up. Thank you, Tornike, for this great presentation, and thanks, guys, for joining us today. See you next week on Wednesday, and thank you and goodbye.
Thank you, guys. Bye.